The industry uses browser terminals to build the most high performance and really productive applications that people are using nowadays. And it's all available through WebSockets and also xtermjs. A few examples include Microsoft with VS Code's integrated terminal, and this provides a consistent terminal experience across platforms. We also have things like Gitpod and GitHub Codespaces, and this is a browser-based development environment that requires zero local setup through containerized terminals. We also have AWS Cloud Shell. This is a authenticated terminal that allows you to access cloud resources without requiring local credentials. We have Google Cloud Shell, which is another one which offers ephemeral environments for cloud operations with pre-authenticated CLIs. And a good one as well is Jupyter Lab, which integrates terminals across notebooks for complete data science workflow, also things like Colab. And you can see that the core idea here is that there's a disposable nature, which is the core innovation, and the containers can be destroyed and recreated instantly, and you get these clean environments for demos, interviews, teaching, testing, deployment processes. So the trick is, this is pretty complex. How do you build it? Well, fortunately, Pragmatic AI Labs has been working hard at building ready-made solutions that allow people to have starter code that helps them build these world-class solutions. So let's take a look at one of the projects that we're going to talk about in a upcoming course on WebSockets. It's zero copy bridging. So there's a Rust implementation that uses direct memory buffers to talk between the PTY and WebSocket to minimize the latency. And this is where Rust comes into play, and scripting languages really fall over, is that you want modern compiled languages, and we also avoid the heap allocations because we use Rust ownership model. So again, because of the very elegant way that memory is managed, right? There is no garbage collection. We can have extremely fast throughput here. We also have actor isolation. So we use Actix in this project that I'm going to show that has an Actix actor model that creates memory-safe concurrency boundaries between terminal sessions. This prevents cross-session data leakage. We also have Tokio task management, and this is a way that async readers can also write tasks and communicate through the channels, and this shows how Rust itself has this amazing lightweight task model versus the traditional thread per connection approach. We also have stateless containers. The Docker files contain multi-stage builds to both minimize the attack surface, but also build a very tight, very small container so that you can have extremely fast throwaway runtimes. And this is another component of Rust that really makes languages that are scripting languages fall apart a little bit in comparison, is that you can build very tiny binaries. You could build a terminal throwaway environment that is maybe 100 megabytes or maybe 60 megabytes, or maybe you could even get into the under 10 megabyte range depending on how you built it, what kind of Linux distribution you're using. And we go through that in Pragmatic AI Labs WebSocket demo with Rust and also xtermjs. And then also we have the WebSocket binary protocol. This explains how binary frames avoid UTF-8 encoding and decoding overhead for terminal control sequences. So really excited about this particular process. And also it's very exciting to really build through all of the different components step by step, show how Rust comes into play, also show how these containerized workflows, especially these micro containers that are below 100 megabytes, really come into play to build these ephemeral environments for terminals. And one of the things I think that's also going to play out as these kind of lightweight container-based terminals that use WebSockets get more and more prevalent is that people may build their own environments for interactivity. So you could build a custom terminal that all it does is have custom commands that interact with your learning platform or with your software as a service platform or your cloud. And you see this already with even emerging cloud platforms. They'll build these own lightweight environment. So do you want to know how to do it? Well, we show you step by step with Pragmatic AI Labs. And this is just one of many really exciting courses that we're building that show really that next level of learning. We want to show you what an industry professional that has 10 or 20 years of experience would build, and using low latency languages and low latency techniques like WebSockets.